All right, so last class we talked about electron configurations. We talked about where are your electrons placed around the atom. All right, what energy levels are they in? What orbitals are they in? And what arrangement do they take? Well, today we're going to illustrate that. We illustrate that using orbital diagrams. Orbital diagrams are simply pictorial descriptions of the electrons that are in an atom. So we're illustrating it or drawing a picture of our electrons. In order to write these, we need to know the rules. So your first rule is the off-bill principle. And what this tells us is that electrons enter the lowest energy orbitals first. All this means is that you need to follow the same order of orbitals as you did in your electron configurations. So your chart that you drew with your arrows going diagonally through it, you're following that same chart in order to fill these. Make sure you fill them in order. Rule 2 says an atomic orbital can hold a maximum of 2 electrons. And those electrons are going to have opposite spins. All right? So let's think about it. My s orbital, it can hold 2 electrons. So how many orbits does it have? How many blanks would it have? How many electrons? It holds 2. Then I'm going to have 1 orbital. Then I have p. Remember, it can hold a total of 6. So 1, 2, 3. Because each blank or each orbital can hold 2 electrons. So to have a total of 6, I need 3 blanks. Remember, our d orbital has 10. So how many blanks would your d orbital have? Each blank can hold 2. So the d orbital would have 1, 2, 3, 4, 5. 2, 4, 6, 8, 10. All right, so there you see. And then your f orbital, I don't have room here for, let's see, f. Remember, it holds 14. And so you have 1, 2, 3, 4, 5, 6, 7. 7 blanks, because each blank can hold 2 electrons. So each atomic orbital can hold a max of 2 electrons, and those electrons are going to have opposite spins. All right, and your last rule is the Hund's rule, which tells us that we're going to fill each orbital up halfway first, and then we get to go back and pair them up. All right, another way, remember we talked about when we looked at the p orbital, which holds 6. All right, here's 1. And then when we added on another one, instead of doubling it up, we drew another one. And then we drew another one. And then once we had our 3, then we could go back and double up. But it wasn't until that was full that we wanted to double. Another thing that might be familiar with this is, for instance, when we had our Lewis dot symbol. And say I'm doing sulfur. Remember, it had 6 valence electrons, and so we put 1 on each side, and then we doubled up. Same concept here. They all want a seat to themselves until there's no more room, and they have to double up. Our electrons are socially distant, and then when we run out of seats, we've got to pair them up. All right? So let's look at the steps that you're going to follow in order to do this. Step 1, find the total number of electrons. That number is equal to your atomic number if that atom's neutral. If it's not neutral, you'll see a positive or a minus beside the atom. Step 2, write your electron configuration, just like we did last class. That electron configuration serves as the basis to know what you're going to draw. So step 3 is to draw your skeleton, remembering that each blank or each box holds 2 electrons. And you all will see them used interchangeably, a blank or a box, right? So S, remember S2, it can hold 2, then it just needs 1 orbit. So sometimes you'll see them as boxes, so then P holds 6, so then it'll have 1, 2, 3. And that sometimes helps you see that those are together with that orbital and that you're focused on that section. Why it says blank or box is as you get quicker with this, you can just do blanks and you don't have to worry about the boxes around it. However, I would stick with the boxes for now because that's going to help you as you're moving forward. All right, so notice it's the same thing, just not outlined all the way. All right, so for example, if we had chlorine, which has 17 electrons, our skeleton would look something like one of these. If you did your boxes, all right, here's your 1s2, and then here's your 1s2 up here as well. All right, then you have 2s2, or you could do a box, 2p6, so I need 3 blanks, because it can hold a max of 6, and then 3s2, 1 blank, 3p6, 1, 2, 3, but remember chlorine has 17 electrons, so do I need all 6? I only need 5. And so again, these two are the exact same thing. One's just showing you using the blanks, and one of them showing you using the boxes. As you can see, the boxes up here make it a lot easier for you to focus on one orbital at a time. All right, so that's the benefit of using the boxes. However, you may use whichever one is most convenient for you once you get proficient at this. All right, and step 4 is to fill in your electrons. So remember your rules. You can only put 2 electrons per blank. They've got to be pointing in the opposite directions. All right, don't overthink it. Just remember they got to point in the opposite direction. And then fill in the empty spaces before you double up that orbital. All right, so let's go back and look at chlorine here. The first thing we're going to focus on is 1s2. All right, so I've got 2 electrons. Let me put 1. You can do a half arrow. It's a lot of times quicker. Half arrow up and a half arrow down. All right, I got to double them up because I don't have any other spots to put them. Then we have 2s2. 1 goes up. 1 goes down. I don't have anywhere else to put them, so they go together. Then I have 2p6. I've got 6 electrons to place. So I've got 3 blanks. I go up, up, up. So there is your 1 electron at a time until you run out of space and you go back and double up. All right, you must always up, 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 then go back and go down, down, down. All right, here is a good way for you to see in this box right here. With the boxes, it's an easy way for you to see what I mean by you've got to fill them all up before you can double up. All right, so I go up. Oh, wait, I've still got 2 more boxes that I can fill up before I would need a double. So I would go up, 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 down, down, down. All right, so that just kind of helps you see with the boxes and those boundaries that that is your p orbital. So then moving on from your p orbital and looking at the s orbital. S has only got 1 blank because it can only hold 2 electrons. Up, down, and then you have 3p5. So here's where I see a lot of questions. I'm like, okay, do you still need 3 blanks if you don't have 6 electrons? Yes. Even if you only have 1 electron there, you must draw those orbitals because they still exist. There's just nothing in them. Think of the seats in the classroom. I don't take the desk out just because there's nobody sitting there. So 3p5, I go up, up, up. There's 3, 4, 5. And I'm done. That's all there is to this. Same exact thing we did the other day. Now you're just drawing your electrons. All right, so let's take a look at some other examples. In your notes, you should have these. All right, so fluorine. Fluorine has 9 electrons. So you always want to give yourself some space above the electron configuration. Your arrows must be directly above the orbital which you are illustrating. They must be directly above. So plan it out and know that you need space. All right, so fluorine, 9 electrons, 1s2, 2s2. I know that my p orbital needs 3 blanks, so let me space it out a little bit more. 2p, and then how many do I need? 2, 4, I only need 5 more. There's my 9 electrons. All right, and so let's go ahead and draw the orbital diagram for that. All s orbitals get how many blanks? 1. All right, here's another s orbital, it gets 1 blank. And here's where I said plan ahead if you're going to need more blanks. 2p5, well, my p's always get 3 blanks. No matter what, you put 3 blanks directly above it. All right, and then we place our electrons. So focus on your s orbital first. Up, down, up, down. That one's full. Let's move on to the next one. Up, up, up. See here, I had 3 blanks that had to be filled before I can go back and go down, down to get to my 5. All right, so that's all you're doing. Let's look at phosphorus. All right, phosphorus has 15 electrons. So let's go ahead and draw or write our electron configuration. I have 1s2, 2s2, 2p6, I'm at 10, 3s2, 12, and then 3p, I need 15, so 3p3. Here's a good example of some of those rules. All right, so first thing we got to do is draw our blanks. Every s orbital gets 1 blank. 1. Here's another s orbital. 1. Every p orbital, no matter what, gets 3 blanks. 1, 2, 3. Now I have another s orbital. It gets 1 blank. P orbital. 1, 2, 3. All right. And so let's go back and illustrate. You need to draw your skeleton first. Your skeleton is your lines. All right. And then you go back and illustrate. So 1, 2. It was an s orbital. I only have 1 blank. All right. 1, 2. Now I have a p orbital. I've got 3 blanks. So 1, 2, 3. Now I can double up. 4, 5, 6. S orbital. 1, 2. P orbital. Remember, what's your rule? Every blank has to have an electron before you can double up. So 1, 2, 3. And you are done. All right? You should never, ever, ever see an empty blank right here. You see this empty blank? If there is something doubled up, this is wrong. You must have 1 electron per blank before you can start to double up. If you don't fill up all of your blanks, that is perfectly okay. You do not have to fill up all of the blanks. Again, just because I don't have enough students to fill up all the desks in my room doesn't mean I take away the desk. All right? These are still seats for electrons to fill if we needed more. All right, let's look at one last one. Potassium. Potassium has 19 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. You see I have 10, 12, 18, 19 electrons. All right, so I've written my electron configuration. Step 2 says to draw my skeleton. Every S gets 1 blank. Every P gets 3. This is why I say plan accordingly for your space. All right. S gets 1, P gets 3, and S gets 1. And then we go back and we fill in our electrons. Up, down. Move on to the next one. Up, down. Up, 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 down, down, down. Up, down. Up, 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 down, down, down. Up. Why did I stop with just 1? Because I have 4s1. So all I need is that 1 there. All right, let's take a look at aluminum. I want to do one more example. So, aluminum. Let's take a look at aluminum. This one's not in your notes, so you can just pay attention up here. All right, aluminum has 13 electrons. So first step, write our electron configuration. 1s2, 2s2, 2p6, 3s2, and then 3p what? 1. All right, next step says to draw our skeleton. Each S gets 1 blank. Oh, this was supposed to be green. Let me do a color that you can see a little bit better. 1 blank. Every P gets 3 blanks. 1, 2, 3. 1 blank. 1, 2, 3. All right, and then we fill those in. Last step is to fill up our electrons. So even if you think that you know what you're doing, pay attention up here and let's take a look at this. All right, 1s2, up, down. 2s2, up, down. 2p6, up, 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 down, down, down. All right, that one's full. Let's move on to the next one, 3s2. I've plotted my 2. And then look at this last one, 3p1. All right, so all I do is I draw that 1 electron. All right, and my other 2 blanks are empty. You leave them there. They still exist. They just do not have any electrons in them. All right, so that's how you do your orbital diagrams. And you have some sheets in your packet to practice this. The first sheet is to fill out your orbital diagrams. And so what that sheet does, if you'll notice, it gives you the boxes. So it already provides the skeleton for you. You just need to fill them in appropriately. All right. So don't get thrown off by that. Make sure you write your exponents, like how I added the exponents to this one right here. All right. You need to add those exponents underneath. That way you know what you need to fill in the boxes above. All right. So that's on the first worksheet. The second worksheet wants you to identify what rule was broken and correct it, all right? Or circle the mistake. I don't think it asks you to correct it. Just circle the mistake and identify which rule was broken. Was it Hund's, Aufbau, or Pauli's exclusion? All right? Ms. Hesse has an answer key so that when you are done, you may come and check it with her.